Hello guys, today we are going to introduce the Doppler effect. So Shen is going to introduce our background of Doppler effect, and Dewey is going to introduce the principle and formula of Doppler effect, and I'm going to introduce the application of Doppler effect. So let's let Shen do it first.
Christian Doppler was an Australian mathematician and physicist. He is celebrated for his principle and known as the Doppler effect. That the principle that observes frequency of wave depends on the relative speed of the resource and the observer. He used his concept to explain the color of binary star. Christian Doppler was born in Salzburg in Australia in 1803. After he completed his high school, Doppler studied philosophy, mathematics, and physics. He began to work as an assistant in university at 1829. At the age 38, he published and introduced his most noble work. In that work, Doppler says his principle, the observer's frequency of wave depends on the relative speed of the source and the observer, that he tried to use this concept for explain the color of binary star while he worked at the university. Okay, this is a picture of Doppler. This is the first concept I'm gonna demonstrate. Doppler effect is changed like a wavelength of light, radiation of sound from a resource due to its relative motion. Doppler found that the wave should have the higher frequency if the source was moving toward the observer, or lower frequency if the source was moving away from the observer. Doppler effect can easily be demonstrated with the sound wave. When a police car passing by, for example, the sound change. The sound wave by the moving police car are pushed closer together by its motion. So its sound seems to have higher frequency, so we call the pitch, that it will have it was parked. In the same time, the sound wave from the recording police car sound as thought they have a lower frequency. The effect occurs because the compression or stretching of wave due to the movement of source. This is the second part, the light wave. The visible light wave are like an electromagnetic wave. Light, sound, and electronic wave all are the form of waveform. The electronic wave are caused by the up and down motion of the electronic field. We see those waves as colored. As you can see, this is red, yellow, green, light blue, blue, pink, red. The colors make up the color spectrum. The Latin name spectrum was given to Isaac Newton to band the color produced by the white light by dispairing it with the prism. A prism is like a three-dimensional triangular shape that can split light into component colors. So that's where we see the sun, the light is red, and they all come like continuously from one end to other. The rainbow is the color spectrum produced by sunlight passing through the raindrops. Each color has different wavelengths, and the red has the longest wavelength. So that's why we see the normally. And this is the third part. How many minutes? This is the third part by waving. As you can see, the police car passing by and the sound from the resource, and this is the observer. The Doppler effect is also for the light wave on the Earth, so it's small that we don't notice. But when we study the straight line of Doppler effect, it's quite noticeable. If we look at the sunlight and other color, we will see the color spectrum from red to the violet. And Evan Hubble used the Doppler effect to determine that universe is expanding. After the year of scientific research, the observation of different celebrate bodies through the telescope, Hubble found that the light from distant galaxy was shifted toward the red end of the spectrum. This rarely shift indicated that stars are moving away from each other. This phenomenon is called expansion of the universe.
Hello, I will introduce this part. This part is the principle and the formula. The principle of the Doppler effect is in classical physics, where the speed of the source and the receiver related to the median and lower than the velocity of waves in the median. The relationship between observed frequency is the f prime and limited frequency f is given by this formula. Okay, where the v is the velocity of the wave in the median, and the wave v0 is the velocity of the observer related to the median. Positive if the receiver is moving towards the south, and the negative in the other directions. And Vs is the velocity of the cells related to the median. Positive if the cells is moving away from the receiver, and negative in the other directions. This formula has the 8 situations. I will introduce each of them. Okay, the first one is when the source is moving toward to the observer. When the observer is at rest, the formula is like this: is f prime equal to v over v minus vs f. This is the formula. And the second one is when the source is moving away from the object at rest. So this formula is like this: the f prime is equal to v over v plus vs f. This is the second one. The third one is when the object is moving towards to the stationary source, like this, and the formula is f prime equal to v plus v9 and over vf. This is the third one. And the first one is when the observer is moving away from the stationary source. The formula is like this: is f prime equal to v minus v9 over V F. This is the first situation, the first situation. And the next is when both number 5 is when both cells and observer moving toward each other like this. So the formula is like this. It's F prime is equal to V plus V9 and over V minus Vs F. This is the number 5 formula. And the number 6 is when both cells move away from each other like this. The cells and observer move away from each other. So the formula is like this. It's F prime equal to V minus V9 and over V plus Vs F. And number 7 is when the source is approached to the standard observer and the observer moving away from it. It's like this. It's a source is approached to the observer and observer is moving away from it. So this formula is like this. It's F prime equal to V minus V9 over V minus Vs F. And the last one is number 8. It's when the observer is approached to the standard source and the source move away from it like this. So the formula is like this. Is F prime is equal to V plus V9 and over V plus Vs F. Is all the 8 situation from the Doppler effects. Okay. Okay. Next.
I will introduce application of Doppler effect. So the most common thing Doppler effect use is the police radar. So like if a police is staying at somewhere to testing the speed and you are driving towards the place. So the radar will show the electronic wave towards the car you are driving, and it will bounce back at a different frequency. So at this time, we can use the first formula, which is F prime equals V over V minus V car. So this V is the speed of the electronic wave, which is same as the speed of the light, and also we need to time the frequency. So now we can find its so it's 3 times 10 to the 8th over 3 times 10 to the 8th minus the speed of the car of F. So the frequency of the police car radar usually be 10.525 GHz, and we can see if the car is moving at some speed, and the police can get a reflected frequency. If your reflected frequency is higher than the speed limit, and you will get in trouble. And the other use of the Doppler effect is ultrasound Doppler ultrasound. which can test the body inside part. So like this is our whistle, and the blood is flowing in your whistle. The speed of arterial and the vein, the blood flow in arterial and vein has different speed. So this is so this is vein, and this is arterial. So like if the sensitive detector has very sensitive detector can send the wave through and get reflect, and they can find the different reflective wave because the speed of this and this is different. So and they can transfer this signal to different color, and we can see the colorful inside body by Doppler effect.